Hi, I'm an old guy and I do maths. And today we're looking at the ambiguous case of the sine rule. Now, what is that about? Well, the short answer is that sometimes when you use the sine rule, you will get two possible answers. And you sometimes then have to do a little bit of head scratching to figure out which answer is the correct one. And what I'm going to try and do here is show you how this all works. Okay, so we've got this example here where we've got a non-right angle triangle and we're looking for angle A. We're looking for this angle in here. And so if we go to work and do the calculations for this, the sine of A over A, which is 10, is going to be equal to the sine of C over 6. Okay? Now, so we'll just go to a separate page. No, actually we'll go down the page. We'll keep this on one page if we can. So the sine of A over 10 is equal to, now the sine of C is 0.5. Sine of 30 degrees is 0.5. 0.5 over 6. Okay, rearranging this, the sine of A is equal to 10 times 0.5 over 6. And I'll just pop that in the calculator. So that is and what we get is we get 56.44 degrees. Okay. So that is 10 times 0.5 over 6, which gives me 5 divided by 6. Sine -1 of that gives me 56.44 degrees. Okay. And if you have a look at this, that all looks pretty believable. Just looking at how this looks, this is a little bit more than 45 degrees, so I tend to buy that this thing is 56 degrees. Now, I want you to focus on this calculation here, what we do for this. Now, this is a perfectly believable triangle. We are looking for A. The angle C is 30 degrees. The length C is 6, and the length A is 10. This is all quite believable. Okay, so what do we do? Well, surprise, surprise, the sine of A over 10 is equal to the sine of 30 degrees, which we know to be 0.5, over 6. Does that look familiar? Now, what's going to happen is this is going to give us 56.44 degrees. And that plainly does not look right. The difference between this triangle and this triangle is that the length AC is considerably shorter, with the result that as that shortens up, the line AB, instead of going that way, now goes this way. Yet we get the same calculation. And so what's going to happen is, if I put this into a calculator, this is going to give me this. And this is clearly not 56.44 degrees. What it is there's 90 degrees there. It's more than 90 degrees. Now, I'm going to spoil the surprise and tell you what it is, and then I'm going to explain it. So, first thing to do is to work out the difference between 180 degrees and 56.44 degrees. And as I'm doing this on a video, I don't want to make a mistake, so I've used a calculator. 123.56. Okay, now we know that according to this and according to this, the sine of A is 10 times 0.5 over 6, which is 5 over 6. So we know that the sine of A is equal to 5 over 6. Okay, now turning that into decimals rather, 5 divided by 6 is that number. It's 0.83 recurring. So it's 0.8333 recurring. Okay, now I'm going to find the sine of 123.56 degrees. Here goes. So sine 123.56 degrees. Take a look at that. It's almost the same. The reason that it's not exactly the same is that there's some rounding in here, and therefore we get that little difference. Okay, so what we discover is that the sine of 123.56 degrees is exactly the same as the sine of 56.44 degrees. Now there is a reason for this, and those of you who are daring enough can have a look in the circular trigonometry playlist, and you will see the following explanation, which I will attempt to do very, very quickly here. There's a thing called the unit circle, and sines, cosines, and tangents are all positive in this thing between 0 and 90 degrees. Sines are also positive between 90 and 180 degrees. And so when we calculate the angle in here for this angle A, what we're doing is we're moving over into this part of this thing called the unit circle. And this angle here, which we find the sine of when we go the sine of A over 10 is equal to 0.5 over 6, is 56.44 degrees. In our other example, this angle here turns out to be 0.44 degrees. Now this is just something that you have to watch out for. It's called the ambiguous case of the sine rule, and it's very easy to spot, because if you get a triangle that looks like this and you do your calculations and you come back with an answer that says 56.44 degrees, what you have struck is the case of an ambiguous sine rule, and what you have found is not this angle but this angle in here. Where it is obvious that the angle is below 90 degrees, just go straight ahead and do the job. Where when you draw out, and I always encourage people to draw out the problem, when you draw out the problem, and you see that this is supposed to be 56 degrees, you go, oh no, this is the angle that I found, and therefore the angle that I am looking for is 123.56. It's that angle in there. I hope this has made this clear. It is quite a bit to get your head around. Thanks very much for watching. If you are still confused, go over to the circular trigonometry page and have a look at the video on why sines, cosines and tangents are sometimes positive or negative. And that should be of some help. Thanks for watching again. See you next time. Bye.